we start with the exponent, right? Exponential function. So let's talk about the exponential function. So typical exponential function look like this. Factor 7, some exponential function, and logarithm function. Exponential. And the logarithm function. Logarithm. Function. Let's start with the exponential function and say, give you the basic model, and we're gonna learn how to analyze it. Right. So this is a very basic model, and then right here, A is called a base, and X is called exponent. Let's start with a very simple one. Let's say f of x equal to x. And typically, let's take a look at. So basically, there's a couple things about this type of function. Before we jump to that, let me show you the graph of the function before we start talking about example. So the typical graph will look like this. So first thing is about this function is the x-axis is what we call the horizontal asymptote, right? So that's the horizontal asymptote. X-axis is the horizontal asymptote. And the asymptote is basically this graph gets infinitely close to x-axis, but never touches it. Gets closer to x-axis, but never touches it. So that's basically the x, and also it passed through this point. This point is called the y-intercept. Y-intercept is 0, 1. Okay. So that's the y-intercept. And then, so basically from left to right, right? From left to right, it's increasing, right? It's increasing all the way. So from left to right, from left to right. It's increasing. Yeah, what else? Let's see. And that's pretty much it. And as x gets bigger and bigger, actually it's increasing at a much faster pace, right? That's another thing. It's not a linear growth, it's like exponential growth. Okay, so that's a typical what this is increasing, right? That's another type. This is when A is greater than 1. When A is less than 1, meaning the base is less than 1, then you're gonna see something like this. So this is what we call exponential decay, right? It's decreasing from left to right. So basically this, so that's two typical type, right? Typical, either increasing or decreasing exponential growth. exponential decay. And this function has a lot of real applications in real life, like how those bacteria grows, right? Bacteria actually grows exponentially, so we can model the growth of the bacteria or like any bioorganism, any organism in the nature. We can model that using the exponential function. And exponential decay, the population, right? Also, people model the population growth using the exponential function. That's a very practical practice for all the countries, right, in the world. Yeah. So, and for exponential decay, the only thing is from left to right, it's decreasing, right? Everything else is the same. First one is x-axis is horizontal asymptote. Secondly, there's the y-intercept. Y-intercept is the same, it's 0, 1. And the third one is from left to right, it's decreasing. And let me give you a couple examples, right? Let's start with the example, which is let's graph f of x equal to 2 to the x. And as we can see, this base a here is greater than 1. So this is exponential growth function, right? Yep. So that the other graph, we just need typically you need 7 order pairs, so I would do 7. X, yeah, and then we're gonna get all those coordinates for this point, and we'll start plotting them. Let's start with for the x values. I'm going to start with the -3. -2, -1, 0, 1, 2. And we're just picking some number from the left hand side with 0, some number from the right hand side with 0, and then find the y values. So we do f of -3 first. That's going to be 2, relation to the third power. Typically, you turn into a fraction with the negative exponent, the denominator, then 2 to the 3, so it's 1/8. So this is 1/8. F of -2 is going to be 2 to -2. So replace x here with the given numbers. So make the fraction 1 over 2 to the square. So that's a quarter. Then f of -1 is 2 to -1st. Right? So that's 1. 1 over 2 to the first is half. Then f of 0, no, it's going to be 1. 2 to the 0, that's going to be 1. That's where the y-intercept is. And f of 1 will be 2 to the first, 2. So that's going to be 2. F of 2 is 2 to the second, that's 4. F of 3, 2 to the third. So 2 to the third is 2 times 2 times 2, that's going to be 8. So this is 4, that's 8. Now look at the pattern here, right? I say x increased by 1 unit, then f of x doubles, right? Double, 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 every step along the way, right? As the x value increases by 1 unit. So the common pattern here is for the exponential function of the base 2 as x value increased by 1 unit. And y value doubles. Y value doubles. So that's basically what we see from this basic exponential function. Now with the graph it by using those 7 points. So that's get all the coordinates here. Let's graph it. So the first coordinate is -3. One of 8. And then the next second one is -2 a quarter. And the third one is -1. Now we get 0, 1, and then 1, 2, 2, 4, and 3, 8. Now we're gonna sketch the graph, but before we do that, we're gonna look at all the y values, all the x values. We want to make sure we have enough points to cover this, right? So I'll put it underneath it. So here, the maximum x value is going to be 8. So we need 8 units here. So 1, 2, 3, 4. And I'll change the color. Five, 6, 7, 8. But that's the maximum we need. On horizontal axis, so it's going to be -1, -2, -3, and 0 in the middle. 1, 2, 3. And start plotting this, right? The first one is -3, 1/8. So it's right here. So this is the half, the quarter, and the 1/8. It's very close to. It's 0.125. So it's very, very close to 0. So -2 a quarter, slightly above it, and then 1 that's half, and 0, 1, and 1, 2, 2, 4, and 3, 8. And then you're just gonna connect them using use a different color. Connect them. We don't want to plan. We don't want to lie, right? So we're gonna just connect them with a curve. Okay, so that's what it looks like. It's maybe label this. Okay, to that. But so any questions so far? We're talking about exponential function with a base 2. Question? All right, so now let's take a look at what if we change the base to half? So let's say f of x equal to half to the x power. Now when the base is a is less than 1, then we call this exponential decay model, meaning it's decreasing on left to right. Decay means decreasing. And similarly, we will get 7 points, just like the other one. So we're going to do X. 1, 2, 3, 4, 5, 6, 7. And we can use the same numbers, right? So there's 3, -2, -1, 0, 1, 2, 3. As a matter of fact, most of the time you can just stick with those 7 numbers. Always works. Right? Next, there's some transformation from for this exponential function. And you have to adjust the number x values accordingly. But most of the time, those 7 numbers works. Okay, let's start with the f of -3. So it becomes half. So replace here, x here becomes -3. So this x becomes -3. Half to the power. And typically, we will just, in order to get rid of negative sign, you will use a reciprocal inside of the parentheses. The reciprocal from 2 over 1 to the third. This is 2, which is 8. This is 8. Second one, up to 2, it's going to be half to the negative second power. Again, flip half, we get 2 over 1 to the second. So this is 2 squared, that's equal to 4. And then f of -1, half negative first. And we flip this, we get 2 over 1 to the first. So it's 2 to the first, 2. And up to 0, that's going to be half. The 0 power, that's 1, right? So this is y-intercept. And after 1, half to the first, half. And after 2, half to the second, that's going to be a quarter. And after 3 is half to the third, which is 1 over 8. Now, once we have all this, again, there's a pattern here. As x increase by 1 unit, right? Go up by 1 unit, 1 unit, then the y value, right, becomes half, 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 right? So this is so this base determines the rate of the growth, right? Basically, how fast does the function go down in an exponential way? So the base is a key factor, or you can say is a determining force to understand this exponential function. Okay, so now let's graph it, right? So we get some 7 order pairs, and 3 is 8, and 2 is 4, and 1 is 2, 0, 1, 1 half, 2 and then quarter, 3 and then 1 eighth. But again, I'm going to put it on the side. I'm going to use a different color here. Here we go. All right, so now again we need some order pairs. We're gonna plot all those order pairs. 1, 2, 3, 4, 5, 6, 7, 8. And on the horizontal axis, we do similar things. So pick some values. 1. Same thing here. 1, 2, 3. Now start plotting all those order pairs. Start with the -3, 8, -3, 8 goes here. And second order, the -4, -2, 4. And then -1, 2. And 0, 1. And 1 half, half is here. And then 2 quarter, 3 1 eighth. right? Something like that. Now we're gonna connect them using a curve. Okay, now extending on both directions. So as you can see, right, x-axis is the horizontal asymptote. It's a boundary line. It's like you're not crossing that boundary line. Right? This is the x-axis, the boundary line. So the functions, the graph, the function is bounded by the x-axis, and also it passes through the y-intercept, and also it's decreasing from left to right. So basically, that's a quick introduction on the exponential function. Do you have any questions for me? Right. No question. Very good. So let's go back to the book and start working on some questions from the web. And also, I have a quick news for you guys. So for the final exam, the passing grade actually, I just received the email from Professor Lawrence last night, and she mentioned that the passing grade will be 60%, right? Not 70. So this is actually very good news for you guys. 10 points less. It used to be, right, the math department, if taking a regular math class, right, 56, the passing grade would be 70. But since this is the immersion program, so they just load the passing grade living for you to easier passing course. Make it easier for you guys. Let's look at 7.1 exponential functions. Okay, let's see. Yeah, so this is the first one. I want you guys to, yeah, let's try to show me another. Okay, so you guys try this, right? Get all these y values, right? Replace x with a 0, 1, 2, -1, -2, get all the values. All right, let's try this. Okay, let's go over the solution. So first of all, in order to get f of 0, you do f of 0. Replace x here with a 0, so 3 to the 0. Any number to 0, 1. That's 1. So 1, so 2, 3 to the first, 3. F of 2, 3 to the second, that's going to be 9. And f of negative 1, 3 to negative first, so that's going to be 1 over 3 to the first, 1/3. F of negative 2, 3 to negative second power, so it's 1 over 3 squared, over 9. Any question about this? So that's going to be 1, 3, 9, 1 over 3, 1 over 9. Yeah, so that should be it. Let's look at the next question. So yeah, we did a half already. So let's try something else. 1 over 7. Let's try this one. All right, let's go over the solution. So f of 0, in this case, replacing x, which is 0, so it's 1 over 7, because 0 power. Any number raised to 0 power is 1. That's 1. That's 1 over 7 to the first. We can meet it, which is 1 over 7. F2, it's 1 over 7 squared. 1 squared is 1, 7 squared is 49. And then, yes, it's 1 over 49. Negative 1, it's 1 over 7. Negative first power. So here, we're going to use a reciprocal inside of the parentheses, 7 over 1 to the first. So 7 to the first, 7. Now for negative 2, it's going to be 1 over 7, 2 at the second power. So 7 over 1 to the second power. 7 squared, that's 49. 7 times 7, that's 49. Any question about this? 1 over 7, 1 over 49, and just 7 and 49. Okay, so yeah, check it. Right, that's good. All right, so let's take a look at this question here about. Okay, let's look at it. So as the car ages, but its value decreases, that's another good example of the exponential decay. And the value of the particular car with the original purchase price of $26,300 modeled by the following function. Where the C is the value of the car at a time t in years. And what is the value of the car when it's 6 years old? And run to the nearest cent. With the total depreciation amount after 6 years. So we are having this exponential model here, and then it tells us time t equals 6. It's 6 years old. Time t equals 6. So basically, we can replace time t here with a 6. Get it? So basically, they want us to find out C of 6. It's 26,300 times 1 minus 0.2 is 0.8. 0.8 to the 6, right? And in this case, we will have to use calculator. This is definitely, you have to use calculator. 26,300 times 0.8 to the 6. So that's 894. So this is $6,894 and then 39 cents. They want to run it to nearest cent. 6894.39. 6894.39. Yeah, check it. Yeah, this is good. And then they want to figure out also the total depreciation. So right now, this is the value after 6 years, right? That means the value of the car goes down from original purchase price 26,300 to this, right? So you do total depreciation will be 26,300 minus the current value, which is $6,894.39. And difference is the total depreciation. And that turned out to be $19,405.61. $19,405.61. Any question about this? $19,405.61. Yeah, they were good. All right, okay. I guess you guys can try one of those. Show me another. Okay, you try this. Okay, let's go over solution. So int as 6 years old. That means the time t equals 6. Equals 6. Now you just go back to the original function, which the value, right? Current value of the car, plug in 6. So it's going to be C of 6 equal to 29,100. That's 1 minus 0.29 to the 6th power. So it's 29,100. That's 0.71. That's 0.71. To 6. Then you need to use the calculator. Let me see if that's a, yeah. So embedded, you're going to use the embedded calculator. You have embedded calculator from the web. Let me see. Nope, there's no embedded calculator. But I can show you an online platform, right, that will let you uh, do some calculation there. It's called a decimal calculator. Yeah, so basically it's a scientific calculator. So you just click on it. And then here you can type in the numbers 29,100 times. Okay, let's see where is it. Multiplication sign times 0.71 to the to the 6th power. Okay. And so that will give you the answer right away, right? So $3,727.72. And we're gonna run it to the nearest cent. You need two decimal place. But since the third decimal is 8, you add 1 to second decimal to end up with a 3727.72. 3727.72. That's the value of the car after 6 years. And the total depreciation, meaning how much does the total value go down, right? We start with the $29,100. Now we only has $3,727.72 remains. So the difference is the total depreciation. If you go back to the, let me show you, go back to the embedded calculator, and that's, so we're going to convert 29,100 minus 3727.72. Okay, so we're going to get this, right? Okay. 25,372.28. 25,372.28. Any question about this? At least 37. Yeah, no, very good. 372. And the other one, it's 25,372.28. 25,372.28. Yeah, that's yours. Okay, nope. Run to nearest cent. Yeah, we did. And maybe I copied the number wrong. No problem. Let's double check here. 3727.72, 25372.28. 25372.28. 4 years. Okay, so this is after the 6 years, right? So they actually asking a different question. So after I overlooked because it's 4 years. So actually we need to do another calculation here. This is not right. So we still got to do one more calculation before we can calculate this. It's the outlook. It should be here. It says 4 years. We calculate the value after 6 years, right? That's okay for the part one, but part two is 4 years. So C of 4 is going to be 29,100 minus 1 minus 129 to the fourth power. And then that's going to be 29,100 minus 0.71. Subtract them first, right? Get the fourth power, then let's get a number. Again, I'm going to show you how to get it done in this online scientific calculator. So here, all you have to do is you can even copy this formula, right? If you don't want to retype it. And right here, we're just going to change the power to 4 on top, right? You get 7,394.80 cents. Okay, 7,394.80. 7,394.80. Now you're gonna do next step. You're gonna do 29,100, the original price minus the remaining values, and get the total depreciation. So now one more time, I'll use a calculator. So it's 29,100 minus 7,394.80. And we get this $21,705.20. 21,705 and 20 cents. Right, that's the remaining. That's the total depreciation. That's how much it goes down in 4 years. Right, that's a lot. So that's why when you buy the car, right, once you own a car, then the car value go down a lot. You know, immediately, right? As soon as you drive it, then the car value go down. $21,705.20. That's the total depreciation. So $21,705.20. Yep, now it's good. Okay. Yeah, so that's one of the application problems. So this is from the find an exponential function. Let's see what else. Oh, this one is a graphing problem, right? Placing one intercept and then one other point on the graph. Yeah, let's try it. So basically, we just need 2 points, right? One intercept and another point, and then the graph will. So I guess you guys gonna try this, right? I'm gonna give you a guideline to graph this function. Okay, so you're gonna use this table right here. X. Only want you to find 5 numbers, right? 5 points. So you do -2, -1, 0, 1, 2. And find all the y values here.
I think we cannot see your screen.
Okay, yes. Okay, thanks, Mark. Yeah, so yeah. Okay, let's go over this. So first of all, we find f of negative 2. So that's going to be 7 raised to the second power. So you're going to make a fraction. And then flip this to a denominator, you get 1 over 7 squared. That's 1 over 49. And then actually, if you do not want to do the calculation for remaining numbers, that's a way to, you don't want to do this type of calculation, right? So base is 7, right? So next number will be 1 over 49 times 7, right? So that becomes 1 over 7, meaning next number will be 7 times as much. So when you put in next number, right, because you pick number in such a pattern, so x value go up by 1 unit, y value go up by 7 units, right? Or becomes 7 times as much. So that's why next number will be 1 over 7 times 7, which is 1. Next number will be 7, right? 1 times 7 is 7. 7 times 7, 49. Right? And basically, we can just pick any 2 points, let's say 0, 1, 1, 7 to graph it, right? Let's go back to the 7 to graph it. So you do 0, 1 and 1, 7, right? You will get the graph 1, 7. Yep. So that will do it, right? Just 2 points. This graph only requires 2 points. Then you check it, it's good. See, okay. Any question about that?
No question.
No? Okay, very good. Let's look at the next problem. It's another graphing problem. Let's see. Construct the graph by using the intercept and then one other point on the graph. So one more time, I'm gonna give you that standard point to plot. And then you guys just find out the y values and we plot it from there. So one more time, let's create a table here. So x, f of x. Are you gonna do negative 2, negative 1, 0, 1, 2? Okay, let's do it. Yep, so create a graph and then we go from there. Okay, let's go over the solution. So first one, f of -2. It's going to be 1/6 to -2. So flip the 1/6, it becomes 6/1. The second, that's 6 squared, 36. And again, another way of looking at the next value, right? It will be because the base is 1/6. So the x increased by 1 unit. And the second number will become 36 times 1/6. Using the previous result times the base, you get next number. So that's 6. The next number will be 6 times 1/6, that's 1. The next number will be is 1 times 1/6, right? This is 1/6. And then 2, yeah, and then 1/6 times 1/6. That's going to be next number, 1/6, 1/6, 1/36. So here we're using the pattern, right? The pattern is the base, generate all the y values. That's another way of getting all the y values. I was just going to use a couple of numbers, right? We're going to use these two. 0, 1, and then 1, 1/6. To graph it. So go back here, 0, 1. And 1, and then 1/6. One over 6 is about 0.17, right? So you just need to get down to 0.17. I think, no, actually, we should use the other one. This is not a, it's not a better. It's very hard to operate, so let me use this. It will be this one. -1 and 6, but that's a lot easier graph. -1 is 6. -1 and 6. This is so much easier. So so we get those 2 points, then it's good to go. Submit the answer, and it's good, right? There you go. Next problem. Now the graphing problem, but this one, it gives us the graph, right? Suppose you take the population of certain strain of bacteria 1 day to double. So let's look at it. In size, right? So it double every day. This is actually true in the biology, right? So a lot of biology phenomena is modeled by the exponential function like this. So it takes the population of certain bacteria, strain of bacteria 1 day to double in size. If the initial population is 100 cells, this is the initial population. The population of bacteria will be computed X days afterwards by using the function. So come out with this function, it double every day, right? So this is population of 3 days. 3 days meaning X equal to 3. Now f of 3 is going to be, go back here, replace X with 3, 100 times 2 to the third. 100 times 8, that's 800. Okay, so it's 800 cells. When will the population first exceed 100,000? This is 100,000. Now here, basically, meaning f of x equal to 100,000. We want to figure out how many days it takes, right, to reach that. So we're going to do this run down to the nearest end of the day. Okay, and that means this whole thing is equal to 100,000. So 100 times 2 to the x power, that's equal to 100,000. Okay. Now I'm going to solve for x Okay, so divide 100 from both sides of the equation first. And cancel that. 2 to the x equal to this. So that was so drop 2 zeros, right? So we get 1,000. Now, in order to solve this, we're going to take the ln, right? ln of the 2 to the x, ln of 1,000. ln is a log with the base e, right? So ln is logarithm with base e. So it's simplified to get x times ln of 2 equal to ln of 1,000. Then we divide both sides of the equation by ln of 2. You get a result. And so that x equal to this. ln of 1,000 by ln of 2. One more time to show you how to get it done in the scientific calculator. So you're going to need ln function. Yeah, right here. Under the function, that's ln 1,000. Close parentheses by ln of 2. So that's so 1 decimal, right? So that would be about 10 days, right? 10.0 days, like about 10 days. Okay, when you run it to the 10th place, you end up with 10.0. So this is approximately equal to 10.0 days, 10 days. And we go back here, 800, right? And then 10 days, 10.0. Yep, they go good. So I'll let you guys try one of these. And another 8 days, right? Very similar question, just slightly different numbers. Okay. Try it. Okay, let's go over solution. After 8 days, that means time t equal to x equal to 8. Yeah, so here means x equal to 8. And go back here, replace x with 8. So f of x equal to 100 times 2 to the 8th power. What is 2 to the 8th? It would be 4 times 4 times 4 times 4. 1024, right? We can also use the calculator. So let me show you. So you do 100 times 2 to the 8th. So it's a, yeah, so it's 2560, right? That's 2 to the 8th is 256. Yes, 256. And times 100, that's 25,600. 25,000. Now, when will the population first exceed 110,000? Is 110,000? So that means f of x equal to 110,000. Now we try to solve by x. So 100 times 2 to the x equal to 110,000. Now we divide both sides of the equation by 100. 2 to the x equal to drop a couple of zeros, 1100. Very similar, you're going to take the ln from both sides of the equation. And then for the ln, x goes in the front, get ln of 2 or ln of 1100. I'll divide both sides of the equation by ln of 2. X equal to ln of 1100 by ln of 2. And we run it to the nearest 10. So one more time, you need a calculator. We can do it by hand. So go down here, get the ln of 1100 by ln of 2. So that's about 10.1 days, right? Run it to 10 days, that'll be 10.1. Answer is 10.1. So 25 that and then 10.8. 25,600 for the first part. And this one is 10. Did it go? Check it. Yeah, they go good. All right. Now, next thing, I want to talk about inverse of function, right? I'm going to show you how to find inverse function. Let's see. The assignments here. Inverse. Yeah, let me quickly show you the inverse. Right. Although it's not here, but it's okay. I can show you. So basically, logarithm and exponent, they are inverse of each other. But let me show you a general way of finding the inverse, right? So find the inverse function of a given function. So let me give you an example. Let's say we have f of x equal to, I'm gonna give you a very simple one. So 3x plus minus 2, something like that, right? And let's find the inverse function of this function. So first of all, step one, you change f of x to 1. Change that into 1. That means this one becomes 1. The second step, you're gonna swap x and 1. Or like meaning x becomes y becomes x. Now it's step 1, step 2. Now y becomes x, then x becomes y. Now step 3, solve for y. So in this case, we get inverse function, but y is not by itself yet. So you're gonna get y by itself. So add 2 first. Both side equation, we get 3y equal to x plus 2. Now we're gonna divide 3 across. So we end up with the inverse function, y equal to 1/3 of x plus 2/3. And now the last step, change y to inverse notation, right? This is inverse notation. Have -1 of x. So eventually the last is the third step. And that fourth step, now inverse, right? Y becomes inverse notation. 1/3 of x plus 2/3. Okay. So that's basically how we find inverse function, right? Very similar with the, so as I mentioned, any question about this? Okay, now I'm going to show you how to get the inverse function of exponential function, right? So as I mentioned, exponential function and then logarithm function, logarithmic function with the same base, inverse of each other with the same base. Inverse function of each other, inverse function. I'm going to show you how that goes. Right? So let's say, let's find the inverse function of f of x equal to 2 to the x. Right? Start with the simple ones. Now, follow this procedure first, right? So first of all, we get f of x of 2x. So step 1, change f of x to y. So this becomes step 1, this becomes y equal to 2x. Right? Yeah. Next, second step. Now, switch x and y, right? Let's switch or swap x and y. So second step, y becomes x and x becomes what? 2y. So third step, then you're going to solve for y. Yep. So here, you want to solve for y, you're going to do log of 2, right? So you're going to take log of 2 from both sides of the equation. So log of 2 or log of 2y, log 2 to y. Now, this is third step. And the last step, so let's solve for y first. So on the left hand side is log 2x. For logarithm, the base and the power of the base are the same. The logarithm has this property ax, it becomes x, right? So here these two cancel each other. Logarithm exponents, they are inverse of each other, so they cancel each other to end up with y. So now y equal to log 2x. Then eventually, last one is change y to inverse notation, right? To f and 1 of x. So this is how you prove, exponents, right? A logarithm, they are inverse of each other. So Yep. So that's basically, that's how we find an inverse function. There's no exercise on this, so we're gonna move on to the next problem, which is logarithm exponents, right? So
Scroll a bit upper, please. I want to take notes. Yeah.
yeah, sure. Make the slide smaller so you can take notes for that entire screen.
I want the relationship of like the
Yeah.
same base
Yes.
writing.
Okay, so exponential function, logarithmic function with the same base, right? The inverse function of each other.
Okay, I got it. Thank you.
No problem. Yes. So that's basically about inverse, right? So there's no exercise on this. So we're gonna next thing we're gonna talk about the logarithm. Okay, logarithm function. So and we can pretty much tackle that because it's a inverse of the exponential function, right? So we know that what inverse means is that x becomes y becomes x. So if you look at this f of x equal to log 2x, right? And let's first of all, let's learn how to graph it. Somebody use 5 points one more time. X f of x. So this time, right? If you look at f of x equal to 2x, we did that earlier, right? Let's say we're using 5 points. X then same 5 points. -2, -1, 0, 1, 2. We did it earlier, right? It's gonna be a quarter and then half, then 1 and 2 and 4. Now if you swap x and y, right? Because they are inverse, that means now x becomes y. All these x values becomes y values. X becomes y, and y becomes x. So now this is a quarter, half, 1, 2, 4. And let's verify this, right? By adding into the logarithm functions here. Okay, so first of all, we find out estimated 2 now quarter, right? The log 2 and a quarter. And we know a quarter is it's 1 to the second power, right? If you flip it, it becomes 2 to -2. So that means this is the same thing as log 2 to -2. Now, because logarithm and exponents have the same base, so they cancel each other. That's how it ends up with the -2. Okay. So half very similar, right? Half is 1/2 to the first, right? And then if you flip it, it becomes 2 to the -1st. So now this is log 2 to -1st. So then this thing gets cancelled, -1 remains. That's why answer is -1. And f of 1 log to 1. So for the logarithm functions, when this number is 1, then it's always 0, right? The answer is 0. And then f of 2 log to 2. Same number 1, right? F of 4 log 2. 4, that's 2 squared. Now one more time, we cancel the 2. For logarithm and the exponent of the base 2 cancel each other. And that's the 2. So you see, so we're using the inverse relationship. Inverse, in essence, is that x becomes y becomes x, right? Actually, we end up with a graph of the logarithm function. So let's sketch the graph. So first one is a quarter 2, -2. Second one is half, -1, 1, 0, 2, 1, and then 4, 2. We look at the y values from -2 to +2. So you just need 2 units, -2, 1, 0, 1, 2. And then that's y values. And x values are from quarter to 4. So you're gonna need 4 units. 1, 2, 3, 4, 4 units. And let's plug in all the points here, 5 points. The quarter is -half. This is half. That's a quarter, -2 right here. And then half is -1 right here. And we got a 1, 0, right? 1, 0 is this. Then 2, 1. And 4, 2. Now if you connect it, you look like this. Okay, so this is basically a graph. If you put in exponential function, right? 2 to the x, I'm gonna use a different color. Let me show you some property about this. 2 different graphs. So -2 quarter. Right, so this is somewhere here, and then -1, it's half here, and 0, 1. Then we get a 1, 2, and 2, 4, right? 3, 4, 2, 4, right here. Now if you connect those, as you can see, this will form a mirror image based on this line right here. In the middle, right? This line is in the middle. And this line is y equal to x. Okay. So basically, these two graphs will form a mirror image based on y equal to x. Let me quickly show you. I probably didn't draw a better graph, but I can show you in the online platform. But drawing by hand is usually a lot more complicated. So because of the unit and everything. So I'm going to show you how to get it done with decimals. Decimal plotting. Between both functions, you will see that how this thing works, right? So first of all, we're going to put in x equal to 2 to the x. Okay, so we see that graph. The second one, we're going to put f of x equal to log 2x. Is that any log? 2. See if this works. Yeah, it does. It does. It actually works. Yeah, it does take log x. And also, I'm going to put in one more one. You see, this is 2, 1. No, it's not a right graph. Actually, I'm going to use log 10. That works. To show my point. 10x, right? And then this one will be log x. Because by default, this is by default, right? If you don't put the index, it will be 10. So logarithm with the base will be 10. And then also one more time, I'll show you why you put the x. Now you can see much better, right? This symmetry, exactly symmetry for the mirror image based on the y equal to x. Yeah, so that's basically the one of the most important aspects, right? That's why this sort of exponent, this y-intercept becomes x-intercept for the logarithm. And yeah, so they are, because they are inverse function, they are symmetrical with respect to y equal to x. Y equal to x meaning y becomes x becomes y. That's why this line is y equal to x. It's for identity function, right? Identity function. So that's how we look at the relationship between those. I'm going to quickly talk about the general. Any question about this? So for the general logarithm, right? For any logarithm function, say. So generally speaking, for f of x equal to log ax, okay. Here there are a couple important things, right? X must be greater equal to 0, right? Greater than 0. So the x value must be always positive, right? Because logarithm function comes from the exponential function. So you can also look at it like this: f of x equal to log a x, right? Now if you turn the f of x equal to y, then actually we can turn the logarithm back into the exponent. You would do this: x here will be equal to log base a raised to y power times this. So you can always switch the logarithm back into the exponent. So because they are inverse of each other. Now let's look at some general property, right? So there are two different types. If a is greater than 1, right? That means it will be increasing. Okay? So first of all, from left to right, in this case, we draw log 2x, right? So 2 is greater than 1, so that's why from left to right, it's increasing, right? There are three different things as well. First of all, is y-axis is asymptote, vertical asymptote. Exponent x-axis is the horizontal asymptote. For logarithm, then y-axis is the vertical asymptote. That's first thing, right? Secondly, there is a x-intercept. X-intercept is x-intercept will be 1, 0, right? Always look there, x-intercept 1, 0. And the third, from left to right is increasing. Very similar, just like the inverse, right, of the exponent. And if a is less than 1, right, be greater than 0, less than 1, a has to be greater than 0, that's less than 1. And three things. First one, y-axis is still the vertical asymptote. And secondly, x-intercept is still 0. And the third one is different, right? From left to right is decreasing. It's decreasing. Okay. Any question about this? So for example, let's say you can have a x equal to log of x, right? And our graph will look like this. Something like that, right? Decreasing. So we'll go like this. Yep, something like that. Okay. From left to right is decreasing. Okay. So that's basically the basic property of the logarithm. So now let's get to the exercise, right? So let's go back to the exercise. Let's tackle some problems on logarithm. So it'll be 7.3. So today, for today's homework, you're gonna, yeah, I'll let you know later, right? We're probably gonna finish this 7.1, 0701, 0703, 0704. So let's look at the 0703 exercise right now. Okay. Yeah, so now I want you to find out what is log 27.3, right? Let's look at it. Okay, so yeah, let's screenshot this. Show you really quickly. So one way to do this is turn it back to the exponent. This will go as, you will treat it as a to the x, a to this x power equal to 2. And then how do we solve this? We can do a is 2 cubed, right, equal to 2. So this is 2, 3x equal to 2 to the first. Same base, then exponents must be the same, 3x equal to 1, then x equal to 1/3. Okay. Any question about this? So we're using the switching the logarithm back into the exponent and solve what I know. So 1/3, right? This is 1/3. Okay. Check it, should be good. All right, so you guys have this, right? Here we go. Yeah, so let's take a half an hour break and we'll come back, take a break, and then when we come back, we will go over the solution for this. Free room. Okay. So let's finish the problem over there. Okay. So you guys finish this problem really quickly. I'm gonna go over solution.
Actually, I went some in my family, so I joined late.
Oh,
Thank you.
so what are you doing? You guys doing this? I'm calling attendance. So, high tech. Are you here, high tech?
I'm here, yes.
Okay, sure. And Barbara is here, right? Let me see your name. And Amaya. And Damijo.
I'm here.
Yeah, okay, great. And Daniel.
I'm here.
Okay. Ceremonial.
Here.
Cedar.
I'm here.
Okay. Ivan.
Here.
Han.
I'm here.
Okay. A quick question, right? How was yesterday's midterm? Everything went well?
I'm not quite sure.
You're not quite sure. Oh, why? That's an issue logging into the midterm?
Yes, Mister. I didn't take the exam because I didn't log into lockdown browser, and Professor Dale he said he gonna mail me another Zoom meeting and then he will show me. And he didn't show me yet. He said yesterday, but he didn't show me yet.
Okay.
Well,
Don't
for
worry
me,
too
I
much, right? Sure, huh? Yeah.
I could take the exam. Yeah. So Professor Dels got back to me and he gave me more time to do the logged out browser trial thing so I could access to the exam early. Yeah. But
Yeah,
at
I
the
was.
same time.
Mhm. Yeah, I tried myself yesterday. I couldn't, I closed out every app, closed out every website. I couldn't log on to that midterm exam though. So that's why I wonder you guys may have a problem. So,
Oh.
but don't worry, guys, right? If let's say you due to the technical difficulty, I will be able to drop your midterm score, right? So don't worry too much. If that's not you couldn't successfully complete the midterm or that was optional grade, right? Just let you know. I have the option to drop that. But the
Yes, thank
final
you.
is sure. So the final is a must, right? Final you need to score 60% or better. And then hopefully by the final time I should have no problem with that. Yeah, that's why I don't feel very 100% confident with that website system, because I tried myself, I have a little difficulty too, So, but I hopefully Professor Dawes will fix that, by the final time. I think they have a lot of experience because they run this program every summer and winter though. So they always use website, So I'm not sure why this time. I think they probably, yeah, maybe just some minor issues. So don't worry too much, right? If you, how about the rest of you guys? How many of you guys were able to complete a midterm yesterday? Maybe anybody can just let me see if I can open the chat. Just I can do a quick survey or something like that. So I would have idea. They haven't sent me the midterm score yet, so I have maybe they will send it to me today. Yeah, but that's okay, right? Don't worry too much. If let's say your midterm score, you couldn't take the midterm due to a technical difficulty, then I will drop it, right? I will drop the midterm score. Your homework score will be more important. So do your homework, right? I will put all the weight on the homework assignments. So I would just drop the midterm exam score. Okay. And we'll not decide the final grade. Okay. And Kang, are you here?
Yes, I'm here.
Okay, very good. Yeah, Victoria.
Here.
Okay, great. And Li Shen.
Yeah, I'm here.
Okay, great.
I'm here.
Okay. And Guang Yu.
I'm here.
Okay, great. Yeah, very good. So, yeah, I just mark it, I mark all of you guys. Yeah. All right, so let's go back. Let's go back to that question really quickly. So again, let me mention that one more time. Like, do your homework. That's very important for you to get a good score, get a good grade in the course, right? Beside the final, and then think about it, right? 60% is very reasonable. Any course, is 60 in the regular math class is like the D minus, 60 between D minus and F, right? So that's a very, very minimal requirement, for you to pass this course. So you guys should, as soon as you do all the homework, right? Now we're gonna do the final review next week, Wednesday, and get you guys ready for the final. I think it should be fine. Okay, now let's just go over solutions here. So we currently back into the exponents, right? So we do 125 to the x 5. Now one more time, this 125 is 5 times 5 times 5, which is 5 cubed. So it's 5 cubed to the x, 5 to the first. So this is 5, 3 times x to the x, 5 to the first. So that means that when the base are the same, then exponents must be the same. X equal to 1, both sides of the equation by 3, x equal to 1/3. Next, any question about this? Okay, let's go back to the, let's input the answer here, 1/3. I should do it. No. System log layout, so let me start writing. So it's good, the answer is good. All right, let's move on to next problem. Yes, very similar one, but then let's try a different ones. Okay, this one is a little too much. Yeah, let's try this one. Very similar to the one we just did. All right, let's go over the solution. So one more time, we're gonna turn it back to the exponent. It'll be 25 to the x equal 125. Then again, 25 is 5 squared. 125 is 5 cubed. The reason why we couldn't leave as 25 or either 25 or 125 because they are not the same base. So we always try to get at the same base. And then 5 is a common one among them. So that's why we're gonna turn into 5 squared and 5 cubed. 5 cubed here, and then multiply those two, 5 to the 2x equal 5 to the third. So 2x equal 3. Now divide both sides of the equation by 2. And x equal 2, 3 over 2. Any question about this? Check the answers. Let's move on to the next question. Okay, you try this, right? It's a very yeah, very similar ones. You just turn it back to exponent, you get the answer right away. Okay, let's go over the solution. So you turn it back as 5 to the negative third equal to x. So base to this power equal to x. And so basically x equal 5 to the negative third. So we just make a fraction, flip it, become 1 over 5 cubed. This is 1 over 5 cubed is 125. So the answer is 125. It's fairly straightforward. Check the answer. That's good. Yeah, this is similar one. We're gonna skip this, right? It's very similar. This is similar to 2 to negative 2. Yeah, we can try one of these. What if it's yeah, let's try this. It's 3 to the x equal to 81, right? When you convert it, how do you solve that? All right, let's go over the solution. So turning back the exponent, you got 3x equal 81. And then 81 is 3 times 3 times 3, 3. So that will be 3 to the 4th. 3x equal 3 to the 4th, then x equal to 4. So answer is 4. Okay, then let's look at next problem. Okay, let's try this. What if it's fraction, right? All right, let's go over the solution. Again, we're going to turn it back into 2 to the x equal to 1 over 16. And 16 is 2 to the 4th. So 2 to the x equal to 1 over 2 to the 4th. And flip it to the top, we get 2x equal to 2 to the negative 4. Same base, right? Always turn into same base. X equal to negative 4. This is one way of doing this. Right? Another way is to show you guys the other way. You can do just keep as is. 1 over 16 and get log 2. And we know 1 over 16 is 2 to negative 4. And when the base for logarithm and the exponents are the same, they will offset each other, right? And negative 4 goes to so the answer is just negative 4. So totally up to you, right? Sometimes one way is better than the other. And this one, it's equally good. So the answer is just going to be negative 4. The answer is 4. Yeah, this is straightforward. So no need to work on this. Let's work on next one. So this one is a graphing part, right? So you're gonna learn how to graph this. One more time. I'm gonna create a file number for you to sketch this. So let me copy the question. And typically, if you draw it by hand, but without the technology, you need at least 5 points, right? So let's say in the final exam, they ask you to graph this, and then in your notes, right, you should show at least 5 points, right? That's a minimum requirement. When you move on to pre-calculus and calculus, right? I teach both, and also on the other courses, usually all the courses will require you to at least graph 5 points. -2, -1, 0, 1, 2, right? Use those 5 numbers, get the y values. No, actually, this is not right. Yeah. I forget, right? So let's do this. Will be 7. So the pattern is you see the base is 7, so you do 7 to negative second power, 7 to negative first power, 7 to the 0 power, 7 to the first, 7 to the second. That's how you pick all those x values, right? Always use the base, and the exponent will be increasing order, increased by 1 unit every step along the way, and then get the y values. Yeah, let's try this. Let's go over the solution here. So the reason why I picked this, because it will give us a we're running y values here. So 7 to negative second power, if you convert it back to the fraction, it will be 1 over 7 squared. 1 over 49. So this is 1 over 49. And the y value, f of um, 7 to negative second power, it's going to be log 7 to negative 2. By doing this, right, the base here, the base for the exponent, because they are inverse of each other, right? So they offset each other. And then negative 2 goes in the front. So the answer is going to be negative 2. Okay. For 7 to the negative 1, it's 1 over 7 to the first, right? Negative fraction, flip to the bottom, over 7. And f of 7 negative 1, it will be log 7 negative 1. So again, this whole thing get cancelled. Negative 1 goes in the front, become coefficient negative 1. Then 7 to the 0 actually is 1, right? So basically, f of 7 to the 0 is 1. This is 1. And log 7 to the 0, that's going to be 0. This whole thing get cancelled. 0 goes in the front. 0. And that's what we call the x-intercept, right? X-intercept for the logarithm function. And then f7, this is 7, that's 49. As you can see, these they are inverse, right? This is reciprocal. These two are reciprocal. So as you can see, x value, right? When the y value go up by 1 unit, then x value becomes 7 times as much, right? Notice that. So because the base is 7 for the logarithm, but because it's the inverse, right, of the exponent, so it behaves like in the opposite way. For the exponent, when x value increase, let's say f of x equals 7 to the x, then our table will look like this, right? So -2, -1, 0, 1, 2, right? -2 will be 1 over 49. And then 1 over 7, right? And then 1, 7, 49. Now it's exactly the opposite, right? Because x becomes y becomes x. Now, here the x increased by 1 unit, then y becomes 7 times as much. Here, y value increased by 1 unit, then x value becomes 7 times as much. So that's exactly the inverse relationship between exponent and then logarithm, right? Logarithm. So now here that will be f7 to the first log 7 to the first is 1. So the answer is 1 here. f7 to the 2. So log 7 to the second, that'll be 2. Now, if you want to draw this by yourself, right? The number is too large, so I guess I'll just use the. Yeah, so we're gonna pick a couple values, right? I think we'll pick this two. It's more reasonable. So 1, 0 and 7, 1. And we're gonna sketch plot those two, right? In here. So first one is 1, 0. The second one is 7, 1. Yep, here we go. So that it's increasing, right? Because the base is 7 greater than 1, so it's increasing the boundary line, right? Or the asymptote is y-axis. See that y-axis asymptote is it's bounded by this y-axis, but never pass through that, right? And also the x-intercept is 0, 1. No, 1, 0, right? 1, 0. Yes. Well, x-intercept is y equals 0, so 1, 0. So you submit the answers, you get it right. Any question about this? All right, so that's graphing of the logarithm, right? Using technology is so much easier, but you should also learn how to graph by hand, right? Let's go to the section 7.4. Let's look at properties of logarithms. Then let's look at it. Properties of logarithms. Yeah, so this is one of the, in order to solve logarithm equations, right? I'm going to show you another. Okay. Green screen. So this is basically a logarithm equation. The way how we solve it is by using some of the properties. So log ax plus log ay. When the base are the same, we add two logarithm, you can convert it, right? So basically convert it as log, same base. Now this addition becomes multiplication x times y, right? And this is the first logarithm property, right? Some properties. Second one is if it is subtraction, let's say f log ax minus log ay, then it's going to be log same base x over y. Okay. And third property is also very useful. It's like log a b to the x, right? Then you're going to put this exponent in the front. So it's x times log ab. This exponent. And also some property we already use, let's say it's aax. Now we know this is going to be just x because these cancel each other. And those four are the important properties we're going to use to tackle a lot of logarithm equations or some type of special operations. So here, because it's addition, right? So this becomes log 7 goes on the bottom, on this as a base, and x times 7, right? So 7x. Now this is basically log 7x. Now we're going to turn it back into the exponent. So 7 to the first is 7x. That means 7x equals 7. Divide 7 from both sides of the equation, we get x equal 1. So using the first property, we get this value x equal to 1. And we can check it very quickly, right? Because it's equation. So when x equal to 1, log 7, 1, that's 0, right? Plus log 7, 7, that's 1, which is 0 plus 1. That's exactly 1. We satisfy this equation here. All right, so that means it's the correct answer. So equal to 1. Yep, that's good. Now you try another one, right? You try another. All right, let's go over the solution here. But again, we're using this property log ax plus log ay. Same base, then keep the same base. Multiply both variables x and y. So same thing here. So we're gonna get log, keep the same base, and then we do 5 times x, 5x. That is equal to 3, right? Now we're going back to the exponent 5 to the third equal 5x, so 5x equal 5 to the third. Then 5 to the third is 125. Now divide 5 on both sides of the equation, x equal 25. And we can quickly check it, right? So x equal 25 and log 5, 25 plus log 5, 5. Log 5, 25 is log 5, 5 squared, right? This is 5, 5 to the first. Now, using the third property is log ax times x. So here is 2. So everything, yeah, 2 plus 1. So that's going to be 3, which is that's the right hand side. That means the answer is good. The answer is 25. Check it. It's all good. Yeah. Now let's look at next problem. Yeah, so you will get a little bit more complicated, right? Like this one, you're gonna get a quadratic equation later. So let's try problem 2. Yeah, let's try this. Let's go over the solution. So first of all, we turn into one logarithm with base 6 for the x times x minus 1. Okay, then equal to 1. Then we turn it back to exponent x times x minus 1 equals 6 to the first. And we can distribute it, right? X squared minus x equal to 6. Now subtract 6 from both sides of the equation. Cancel that to the x squared minus x minus 6 equals 0. Now basically have two solutions here, x 3, 2. A couple solutions, x minus 3 equals 0, x plus 2 equals 0. First one, f3 from both sides of the equation, x equals 3. And second one, you add subtract 2, both sides of the equation, then the x value equal to -2. So we do have two solutions. That's true. Is that true? We have two solutions. Not really, right? One of the solutions is not a valid solution. You see that. So you gotta check both. First one, check x equal to 3. We get log 6, 3 times log. Now I'm adding log 6, 3 minus 1, which is 2. Get log 6, 3 times 2, right? 6. Log 6, 6. That is equal to 1, right hand side, which is good. But the second solution is not good, right? It will yield because for logarithm, this must be greater equal 0, right? This x here, this whole thing here must be greater equal greater than 0 and not 0. So that means when you plug in -2, both logarithm being the domain is being violated, right? So meaning it's not part of the domain. So you get first one is log 6 -3. This is not okay, right? Last log 6 minus 2 minus 1. This is also not okay. So basically, this is not part of the domain. So undefined. Logarithm is undefined. Basically, no solution. This solution is not good. So we're gonna cross out this solution. Right. So the only solution is actually 3. So be careful, right? When you have quadratic equation, typically one of the answers is not good. We gotta double check by plugging back the value into the original equation. So here it's only going to be 3. 3 is the only solution. Yep. Any question about this? Okay, let me quickly check this assignment right here. See if I should probably I do it. It doesn't generate. That's okay. And I go back to this. The question number 2. Which should be the question 3. It's also similar one, so and quickly have this. Okay, let's go over solution. So first of all, please back to single logarithm expression. So x times x 6 and equal to 3. Now use conversion to turn the exponent times x plus x equal to 3 cubed. So that's 27 x times x squared and 6x equal 27, and subtract 27 from both sides of the equation. X squared plus 6x minus 27 equals 0. I'm going to factor this x plus 9, x minus 3. Two solutions, x plus 9. And one of them is not a good solution. Subtract 9, we get x equal -9. This one is fourth solution, right? We're going to eliminate it. The other one is good, adding 3. So the answer is 3. Right here, you're putting first solution x equal -9. We're going to get that log 3 -9. And this is not allowed. The reason why it's not allowed, think about this. Log 3 -9, right? Equal to a number, let's say x, right? And if you turn it back to exponent, you get 3 to the x equal -9. That's never happening, right? For the logarithm, for the exponent, this is always going to be 3 to the x is always greater than 0. So it's never going to be -9. Doesn't happen. And that's the reason negative number doesn't work. The same thing for the other one. You put in -9, you get log 3, actually, and this is not okay. So this is basically it's invalid solution. So get rid of it. So the answer is just going to be 3. Any question about this? Check it. That's good. All right, so this is like the condensing the logarithm expression. Show another, yeah, this one shows another. So let's do it. So basically, we're going to condense into a single logarithm. So we're going to use a couple properties, 3 properties, right? First one is when you add, becomes same base, multiply x and y. Then when you subtract the same base, this is log a x over y. And the third one, if there's an exponent right in front of the logarithm, let's say b times log ax, then this will become log a, and b will become the exponent for the x, so actually b. So applying those 3 properties, you'll be able to tackle this. So step 1, put back all the coefficients, right? All the coefficient becomes exponent. So this becomes log b x squared minus log b y squared plus log b c cubed. Now you have to put back the coefficient before we apply the other 2 property. So now addition, right? This to addition. Addition becomes multiplication. Log b x squared minus z cubed. And then subtraction here becomes a division. So divide by y squared. So that's how we condense it into a single logarithm. Any question about this? So log x squared. So we need a fraction first. X squared minus z cubed. and then over y squared. Yep. Then I should do it. No, this is not square root. Yep, I should do it. So the answer is good, right? Now you try another one. Try this one. Okay, let's go over the solution here. So first of all, we put back all the coefficients. So that gives us log e x squared minus log e y squared plus log e z to the fourth. So all the coefficients becomes a power for all the variables. The next thing is addition becomes multiplication, and subtraction becomes division. So same base would be x squared times z to the fourth over y squared. And let's do it. X squared z fourth over y squared. That should be the answer. Check it. Yeah, it's good. And this is a similar one. I like to try, right? You're going to turn into log 2a and figure out what is a here. Okay, let's go over solution. First step, we'll put back all the exponent, the coefficient, right? With exponent. We get that log 2. To the fifth, first term, second term, log 2, y to the second. Third one is log 2, z to the third. Then the addition becomes multiplication, subtraction becomes division. Keep the same base 2 x to the fifth times z cubed over y squared. So that means a equal to this are parentheses to the fifth times c cubed over y squared. Any question about this? x to the fifth e cubed over y squared. Okay, that should be the correct answer. Yeah, let's look at when the coefficients half, right? That and then 1/5, you basically follow similar pattern. I'll just make the exponent and then combine them. And I'll actually try it really quickly. All right, let's go over the solution. So put back the coefficient. So get log 2 for the 1/5 minus, no, 1/7, 1/2. First one is 1/2. The second one is 1/5. 2 y 1/5. Now subtraction, so that becomes division. So log 2 times half over y to the 1/5. And that's the best we can do. We can leave it as is. So here a equal to x half over y 1/5. We're just going to do fraction first, x half, and then y 1/5. Should do it. Yep, that's good. Yeah, so this is and this one is interesting, right? It's like breaking down the logarithm. Right now we have single logarithm. You need to break it down. Yeah, let me create a new version. I'm going to show you how to do this, and also the properties we can use. So basically, it's going backwards. Earlier, we are doing condensing into single logarithm. Right? Now, when you have single logarithm, you can break it down into different component. That's what we try to do here. So now I'm show you all these properties, right? Let's say you've got a log a x to the e power, y to the c power, and then z to the d power, right? And basically, you can break it down as this, right? So division will become subtraction. So we get multiplication become addition. So it's log a x e plus addition becomes addition, log a y c. And then minus division becomes subtraction, log a z to the e power. And I put all the power in the front, make it coefficient. So e times log ax plus c times log ay, and then minus e times log az. But if you're going back to the original, right, let's say the multiplication, so earlier we have log a x times y, right? I can break down as log ax plus multiplication becomes addition log ay. So going backwards, right? Or we're learning this direction, now we're learning going backwards. Just the same property we are using. Second one, if it is division of a x over y, then it becomes subtraction log ax minus log of y. And also, if it is exponent, right? Let's say log a x to the b power, and the b goes in the front. And log a. So basically, just using those three properties, we'll be able to split up. So first of all, we get log 10, and the square root of x. Remember, we can always turn this into exponent by keeping the base, do the power by index. So this becomes x to the half. Similarly, let's say cubic root of x, right? And it becomes x to the 1/3. For also fourth root of x becomes x to the 4th power. So vice versa, right? So basically, you can go back and forth for the square root and then the exponent convert back and forth. So we get a square root here, which is this x to the half I square over z to the 5th. Now this multiplication becomes addition, division becomes subtraction. So we get log 10 x to the half plus multiplying plus log 10 y squared minus log 10 z to the 5th. And then all this power, right, becomes coefficient. Okay. So half goes in the front, that's log 10 x plus 2 goes in the front, log 10 y. And then this one, 5 goes in front, log 10 z. So basically, it's half goes here, and this 2 goes here, and plus minus 5, and minus 5 goes here. All right, any question about this? Half goes here, and 2 goes here. Now, last one is minus 5, but this one is a little bit tricky. They just want you to include a sign to be part of the coefficient to -5. Can I check the answer? Yeah, it's all good. Okay, now you guys try another one. Let's see if there any cubic root or square root. Yeah, let's try this one. All right, let's go over the solution. First of all, you're gonna convert this square root of x as x to the half. And then get this 10 x to the half, y to the fifth, and then z to the fifth. From there, just turn it multiplication to addition x to the half plus log 10 y to the fifth minus division becomes subtraction minus of 10 z to the fifth. Now put all the put all the power in the front. Make the coefficients of half like log 10x plus 5 times log 10y. And minus 5 log 10z. So the answer is going to be half of here, 5, -5. So that should do it. Submit it. So get all the answers. It's good. Okay, you quickly try this one. And we get this all the exponent now, and you want to convert it back to the expanded form, and I get a, b, and c. I find a, b, and c. Okay, so very quickly, so all this becomes 3 different terms of 2y to the 11th, and then division becomes subtraction of 2z to the 12th. Z to the 12th power. And we make the power goes in the front with a coefficient of 2x. 11 times log 2y minus 12 times log 2z. They will only want a coefficient a, b, and c. So 6, 11, and 12. All the power becomes a coefficient. Oh, they want a plus, right? So that because it's minus, so that should be minus. Overlooked. Because they want a plus minus 12, so they want to include the sign. Yeah. So minus 12. Okay. And let's try this one again when we are going. So 3 log, you want to turn into single logarithm. Okay, let's go over this. So first of all, you put back the coefficient at the power, so log 7 x squared plus log 7 y squared minus log 7 z to the 5th. Once you put back the coefficient, now the addition becomes multiplication. Making sure they have the same base. Then x squared times y squared, and subtraction becomes division, z to the 5th. Yeah, so that's x squared times y squared with z to the 5th. And then check the answer. That's good. Yeah, then the last thing I want to talk about is the change of base, right? Which is section 7.5 in our homework assignment. So we're gonna learn how to change the base. Okay. And this is changing the base. Let's look at this question right here. Show me another. Okay. So basically, two important logarithms, right? Logarithm with base 10 and then logarithm with base e. Those two are the important logarithm because for the most of the calculator or like the online platform, they only take log e or log with base e or log with base 10. And like the one I graphed earlier, right? Only log with base 10 works. So any other base, we're gonna learn how to convert and change the base. So I'm gonna show you how to do a change the base really quickly. So change the base formula, it's actually very straightforward. Change the base formula. Let's say you get a log AB, right? Now you can basically turn into a quotient of the two logarithm. First one is let's say using C, and use base C, okay, log CA, right? So we put a B on top and then CAA on the bottom with the same base. So similarly, we can turn this log AB, any base, you can turn into log 10B over log NA. This is something you can look at. Also, we can turn into log with base E, right? In Ln. So log AB could be written as Ln of B over Ln of A. And these two are the most common ones. This is basically the change of base formula. And then, so anything you try to look for, right? We can do that. So in this case, let's use the change of base formula to solve it. Okay, right. Basically, we're gonna use a base 10, right? Or base E, whichever you prefer to use. So do log 10, 5x, and log 10. Now, we're taking the logarithm with the same base on both sides of the equation, and then that equation stays the same. So right here, to put an x in the front, the log 10, 5 equal log 10. Yep. So now divide both sides of the equation by log 10. Cancel that myself, and they want to run the 3 decimal place. Now, if you go back to the calculator, right? I'll show you. Maybe it's not a calculator, so I'm gonna go to Google and type in decimals. You can use your own calculator. I just want to show you if you want to do calculation in this platform, calculator, and then scientific calculator. Then we can go back to the function. You do log. By default, that's base 10, right? Log 9 over, is it log? Yeah, log 10 9, right? Yeah, it is over log 10 5. So anytime if you do not see logarithm with base, by default it's base 10. And then divide by log 5. Close it. And we get this. We need 3 decimal place, that would be 1.365. Like 1.365 with roundings. So go back. I forget to share. We go back here. Using this decimal scientific calculator, you get log with base 10, 9, log with base 10, 5. And then find the quotient of those two. You get 1.3652123889. Run to 3 decimal place will be 1.365. So the answer is 1.365. Approximately equal to 1.365. We go back, the answer here 1.365. So basically, that's how we utilize the change the base formula to tackle this. All right, you try one of this, right? Yeah, try this one.
Hello, sir.
Yes, I'm here. Yep,
I don't see on the whiteboard 7 was the change of base homework.
it's not there yet.
Yeah,
Okay, let me double check. Maybe I haven't assigned it yet. 1 second.
Okay.
Maybe I forget to assign it. 1 second. Okay. 7.6. But I have to get a sign. Yeah, I'm assigning that right now. I should be able to see it in a second. You should be able to see right now. Check it. Refresh the screen. Refresh the web browser. Right?
I see. 706. Yes.
Very good.
Thank you.
Yeah, sure, no problem. Let's go back to this question here. Question 2. Okay, let's go over the solutions. So we're gonna change the base, either change base, turning the base 10, right? So log 10, 3x, and log 10, 5. You can also take an ln, right? It doesn't matter. So x goes in front. I'm gonna show you both. Second and 5. Right now we divide both sides equation by log 10, 3. Cancel that x is by itself, so that we get 3 decimal place. And log 10, 5. Also, you can do ln, right? Let's say you're taking ln, react ln of 5. Result will be the same. X goes in the front, so x times ln of 3 equals ln of 5. Now divide both sides of the equation by ln of 3. ln is logarithm with base e. E is what we call natural number. E is natural number, or the older number, natural number. And then E is approximately equal to 2.7183182 with infinitely many plates, right? Like pi. Yep. So basically your base 10, that's 2 options we have. ln of 3, then we get x equals ln of 5 or ln of 3. And let me show you, they actually yield the same result. I'm gonna go back to the calculator here. Maybe do ln of 5 over ln of 3. We get this 1.465, right? And then if we do log 5 over log 3, same result, exact same result. You see that same result, 1.465. If you run it to 3 decimal place, they're exactly the same. So totally up to you, right? If you want to change the base E or base 10. 1.465. Excellent result. Yeah, that's right. Let's go back to, yes, I think we will we'll stop here. We don't have enough time. So the rest of them is very similar, right? A lot of them are very similar to the one we have. Just with a little tweak. I'm gonna go over some of them tomorrow, and then we're gonna start talking about the last topic in our program, is trigonometry, right? We're going to talk Monday. We will introduce the trigonometry, and also Tuesday we're going to continue on trigonometric identities, and Wednesday we review for the final exam, and the final exam. And the final exam is already posted. Review has been posted in the website. Okay, when you log in, you should be able to see that, and we'll go over all of the questions there. Okay, so any question before we end the class?